This lesson is to show how to use the basic unit circle definitions of the 6 trigonometric functions: cosine theta, sine theta, tangent theta, cotangent theta, secant theta, and cosecant theta, given at the right here. How to use these basic definitions to evaluate any one of these functions at a special angle, just kind of using what we know about sine and cosine. So let me first sort of mention that the way these are written, for example, tangent theta is y over x, these are often written a different way. There's something called the quotient identities. And the quotient identities are, for example, that tangent theta equals sine theta over cosine theta. Since tangent theta is y over x, and sine theta is y and cosine theta is x, one way that a lot of people think of this is, oh, tangent theta is just the sine of theta over the cosine of theta. Similarly, if I look at cotangent theta is x over y. Okay, well, x over y, that's just cosine theta over sine theta. So often they'll say cotangent theta is cosine theta over sine theta. The other type of basic identities that we study are called the reciprocal identities. And so reciprocal, you'll remember, is just 1 over. Like the reciprocal of half is 2, and the reciprocal of 3/4 is 4/3. It's just whenever you go 1 over a number, that's its reciprocal. And so, for example, secant theta is 1 over cosine theta. Cosine theta is just the x, secant's 1 over x, so secant theta is 1 over cosine theta. Cosecant theta is 1 over sine theta, and even cotangent theta is 1 over tangent theta. Just they're reciprocals of each other. Tangent theta is 1 over cotangent theta, for that matter. So I mention this just because you'll see these things written the way I just mentioned, and hopefully at some point you get to the point where it's all the same thing. But what we're going to do is we're going to kind of use these special values, all along here, all these special values, and I didn't circle very well just because I don't have space on here, but I'm going to do a couple of examples where we evaluate one of these just thinking about these special ordered pairs that we get at these special angles. So the first one I'm going to do is the cosecant of negative pi-fourths. So the first place I start is to actually go, well, where is negative pi-fourths? And we say, all right, starting there at 0, going in the negative direction, a quarter of the way through pi, and there's negative pi-fourths. Then I remind myself what this ordered pair is. And when I do that, I go, okay, well, the x-coordinate and the y-coordinate, I'm hoping I remember, look about the same. Here's the x-coordinate, here's the y-coordinate. It's about the same spot, the same size, if you will. Yes, one of them's positive and one of them's negative, but just looking at the size of these coordinates, they're about the same. So that will help, number one. And number two, just looking at it, it seems like, 1, 2, 3, 4, 5, 6, 7. Yeah, it's about negative 0.7 for both, negative 0.7 for the y, 0.7 for the x. So just through that estimation, I'm going to be able to say that, okay, so the coordinates here are square root of 2 over 2, about 0.7, negative square root of 2 over 2, about negative 0.7. And have some confidence that it's those values rather than maybe some of these other ones. All right, so how is that going to help me? Well, I go, okay, so cosecant, I remember, cosecant of an angle is just 1 over the y-coordinate, or if you will, 1 over the sine of the angle. Okay, well this 1 over the y, 1 over the y means flip that fraction over. You know, 1 over is the same as reciprocal, which is the same as flip the fraction over if it happens to be a nice fraction. So negative 2 over the square root of 2. But we like to rationalize these things, and so what we're going to do next is say, okay, how do I get rid of that square root of 2? I'll multiply top and bottom by the square root of 2, so that the top is now negative 2 times the square root of 2 over square root of 2 times square root of 2 is square root of 4. That's just 2. Schwack, schwack. Final answer, negative square root of 2. So the next one I'm going to do just a little bit quicker. So this time I'm going to look at what is the tangent of 5 pi thirds. So I go, all right, pi thirds. So pi cut in thirds. There's this pi downstairs cut in thirds. There's the pi upstairs cut in thirds. If I'm going to count this, let's see, there's 1, 2, 3, got me to plain old pi. 4, 5. So got to here. Positive 5 pi thirds. Now I'm looking at the coordinates of that point and realizing that the x-coordinate's about a half, so let's go with that. Must be a half. It's not 0.7, it's not 0.9, so we'll go with a half. And the y-coordinate, negative, and it looks like around 0.9, so let's assume that's negative square root of 3 over 2. Because it's a special angle, it's going to have one of these special exact values. It's got to be that one. So the tangent, I remember, tangent of theta is the y over the x, or if you will, the sine over the cosine. And so it's the y negative square root of 3 over 2 over the x. So I'm going to think of this fraction bar this time as division and call that negative square root of 3 over 2 times 2 over 1. My favorite thing to do in algebra, schwack, schwack, negative square root of 3. All right, one more to illustrate something that comes up sometimes. So this time, I'm going to look at the cotangent of negative pi. And cotangent, we remember, cotangent of any angle is going to be the x-coordinate over the y-coordinate, cosine over sine. So I need to figure out the x and y coordinates of negative pi. And I go, oh, okay, so this is just x is negative 1, y is 0. Okay, cool. So this is just the x over the y. Oh, wait a minute. 0 in the denominator, that doesn't fly. This value is actually undefined.